2015 Set 1 Electrical Question number 12. A steady state current is flowing in the direction x through each of the two infinitely long wires at y equal to plus minus L by 2. The permeability of the medium is mu0. The magnetic field is being asked. So, as you know, in order to solve this question, you need some knowledge of Ampere's law, because currents are given and coordinates are given, and you are being asked to find the magnetic field at 0L0, that is at a point that is lying 0L0, so here about this point. So useful data you need is Ampere's law, which states that if I have a current I and I have an enclosure, then integral H, line integral, that is H dot dl, that is around this enclosed enclosure, is nothing but I. Now, in order to solve this question, we need to find H net equal to how much for a system like this, where this is X, this is Y, this is Z, and the two wires are placed here at minus L by 2 and plus L by 2, and here the H net is being asked. So H net is an effect of both the wires, wire 1 and wire 2. So due to 1 and due to 2, the net magnetic field intensities must be considered. Now H1 equal to, now what you need to do, you need to take the enclosure, placing it at the center such that you can do the integral and H becomes constant for all points on this enclosure. For 1, for 2, you take this enclosure such that H is constant across all points on this enclosure, right? So be careful in your enclosure selection so that the integral becomes easier. Now this is radius, a circle of radius L by 2, because it is already placed at L by 2. So having L by 2 as a center, if you take the enclosure, so at this point you need H net, which is nothing but I. So I, which is enclosed, divided by the circumference. So in line integral you did H was constant, and integral over the line gives the perimeter. So the circumference is 2 pi L by 2. So for H1 this is H2. So H2 you take this enclosure, which is nothing but L by 2 plus L, right? Because this point is A0, L0, so you take Li by 2 pi. So L plus L by 2 is 3L by 2. Take C only the distances, not the signs, right? This is 3L by 2 and this is L by 2, right? Now, so the answer will be magnitude of H net equal to, because both are in the same direction, right? So this is in the z cap direction, this is also in the z cap direction. You see, if you place your thumb in this direction of going the current into the plane, and this point you will find your fingers, that is your right thumb you use, and you use your thumb and your fingers. If your thumb is pointing in the direction of the current, your fingers curl direction will point in the direction of the magnetic field intensity. So if you are at this point, you place your right thumb finger in this direction of current, then your finger curling direction, when you curl your finger, that direction is coming downwards, so this minus z cap. And also for this point, that is current at point 2, this point is coming down, the direction is coming downwards, so both can be added. So it is coming out to be 2 plus 2 by 3 I by 2 pi minus AK cap, okay, or AZ cap I can say. So it is coming out to be 8 by 6 I by pi L minus Z cap. So this is nothing but 4 by 3 I this. But you see, so B equal to mu H, where mu is free space, permittivity of free space. So we found H. Now B is mu into H net, where H net is this, so mu is B is mu 0 into 4I by 3 pi L, and direction is minus AZ cap.